the neon green sheet is where I got these guys here. Okay? So, inverse, you guys know that little -1 means inverse, right? We talked about that yesterday. Sine, cosine, all the trig functions also have another option. Sometimes they'll be called arc. Arc cosine, arc tangent, arc sine, arc secant, so on and so forth. That also means that's the same thing. So the -1 symbol or the word arc before it is both means the same thing. They both mean inverse, okay? Because some of these you'll see arc, some of these you'll see the little -1. You won't see them both, but you'll see one of them, okay? So here's how we're gonna do it. Anytime they want inverse of sine, we're gonna use this roadmap. These are kind of roadmaps on what to do. So just depending on which one it is, it's not that bad. It's not bad at all if you guys know these. These are the types of things that I would put on my card for tests, because to memorize these is not necessary if you get to use a card, because you don't need to memorize the derivative of arctangent is u prime over 1 plus u squared. That's not necessary. Put them on your card. Just put those on your card, okay? So that if you do have an inverse sine, inverse cosine, things like that, you can look at your sheet. You can look at your card. All right. Okay, so let's look at one. So the question says find the derivative, okay? And the function is an inverse function. It has that little symbol here. That little symbol here, okay? So anytime we're doing that, first thing I'm going to do is go look at my table. Either you can go to these notes or go to your green sheets. Go to your green sheets and figure out where arc or inverse cosine is. It's right here. So it says, if you have one of these guys, right, use the stuff in parentheses. The first thing you're going to do is take negative the derivative of the stuff, okay? So it's really a -1, so I'm just going to put, instead of a negative, I'm going to say -1 times the derivative of the stuff. Well, the stuff is x squared, so the derivative is 2x. Okay, that's the top. The bottom says the square root of 1 minus the stuff squared. U is the stuff in parentheses. So square root 1 minus u squared. Yep. So you don't have to find the derivative this time. You just write whatever u is. U in this case is x squared. All right. So now what we're going to do is just simplify it as far as we can. So the top would be -2x. The bottom is going to be the square root 1 minus x to the 4th. Done. That's as far as you need to go. I don't need you to go any further than that. You're done. When you see these will most likely be multiple choice questions. These are multiple choice questions, and you don't see them often. Like, you could do a whole practice AP test, all 40 questions that are on it, and you might see one of these guys. You might see. They don't happen a lot. But I didn't want to skip it just because you do see it, so I always go over this. But inverse, like I said, you can take a whole practice AP test and not see one. Sometimes you'll see one, no more than one. So they are important, but they're not as important as the other things that we've done. Okay? All right. So now we got inverse sine. Okay? So let's go to our inverse sine is the first one. Stuff prime. So the derivative of the stuff. Okay. So in this case, the stuff is the square root. This is the stuff. They didn't put the parentheses around, but that's the stuff. So if I'm going to find derivative of that, I'm going to do what you've done for a few weeks now. Change it to a power. It's really 2x parentheses 1/2 power. To do that, you're going to use the chain rule. So we have an outside, and then we have an inside. So if you're going to find derivative of that, we're going to go 1/2 parentheses 2x, subtract a power, negative 1/2, times the derivative of the yellow, which is 2. That's going to go on top. 1/2 parentheses 2x, negative 1/2 times 2. Bless you. I'm not done with it. We can multiply and stuff like that, but for right now, I just want to do the derivative. That's the derivative of the top, which it said to do. Okay, let's go to the bottom now. Not done with the top yet, but for right now, I am. Exactly like what it has with cosine, right? The bottom is exactly the same. All of these are very identical. All of these are, that's one of the reasons why it's hard to memorize, because they're all very close. So I wouldn't even try to memorize it. Just write them on your card when you're taking a test or a quiz. So it's the same thing. Square root 1 over u squared. Square root, oops, 1 minus u squared. U is square root of 2x. Okay, now I'm going to simplify the top. So when I simplify the top, 1/2 times 2, just 1. So I get 2x to the negative 1/2. The bottom, I can simplify a little bit too. 1 minus square root of 2x squared. Well, the square root of 2x squared is just 2x. Anytime you square a square root, it just goes away. Last thing, move this guy down, because it is a negative power. So you're going to get nothing left on top. Well, there's always got to be something, so there's a 1. So on bottom, you're going to get 2x to the 1/2 times the square root of 1 minus 2x. You can change it so that they both have now, that's not totally simplified, but for this, I'm okay. Keep it like that. You can multiply, since they're both square roots, you can multiply the square roots and go a little further, but I'm not worried about that. I just want you to focus on this. Focus on the rules. Okay? So is that like the totally simplified answer? No. But I'm okay with you guys stopping there. Okay? I just want to focus on the rules today. I don't want to focus on the simplifying and stuff like that. Okay? All right, we got 2 more, and then if we have time, I'll give you another one, and then we'll be done for today. All right, so let's go to C. C's on the last page. Okay, so I want you to look at C. First thing I want you to do, before we write down anything, set up a plan. What rules am I going to have to use to solve this guy? First of all, what are all the rules I'm going to have to use?
The chain rule.
Chain rule where? Yeah, Seth, tell me where the chain rule is going to come into effect.
The second part of it, where it's the square root of 1 minus x squared.
That's going to be a chain rule, right? Okay.
As well as the sine negative 1x.
Yeah, so we're going to have to deal with that, right? We have this guy, but we have our table, so we're good there. What other rule am I going to have to use to solve this guy?
Product.
There's one more, yeah, the product rule, because these are multiplication. This is multiplication. Okay. So I'm going to rewrite it. First thing I'm going to do, now that I know all that, first thing I'm going to do is rewrite it. So I get x times the inverse of sine plus, and then I'm going to write this as a power, no root. Okay, so the plus is going to come straight down. On the left side of the plus, I have to use the product rule. On the right side of the plus, I have to use the chain rule. Okay? All right, so let's do the left side first. So the product rule says the first times the derivative of the second. The derivative of the second is it's an inverse. So I'm going to go back up here. Inverse sine. Stuff to the first power, or not to the first power, the derivative of the stuff over 1 minus stuff squared. Okay. So the derivative of the stuff is just 1, because the derivative of x is just 1. And then on bottom, it's 1 minus stuff squared. And the stuff is just x plus. Now the other side, the derivative of x is 1 times the second. Okay. Now the blue. The blue is the chain rule. So I'm going to move the 1/2 to the front. Subtract a power times the derivative of the inside. Negative 2x. All right. So now I'm going to write this. So this is x over 1 minus x squared square root plus sine, inverse sine, I should say, over here. These guys are going to have to move down. So we get 2, 1 minus x squared, 1/2, negative 2x. Okay, and then I can divide the 2's. So you get x, 1 minus x squared, plus inverse sine of x, plus negative x over squared. There's one more step. Does anyone see that step?
You put the fractions together.
Yeah, they have this common denominator, right? These two fractions have a common denominator, so I can add them together, right? What do I get when I add them? 0. Yeah, because you just add the tops, right? X plus a negative x, 0. So those guys just cancel out. So what are you left with? What's your final answer? Inverse of sine. Okay, again, It's not the calculus part. That's the heart of it. That's the hard part about this. It's the multiplying, powers, all that stuff. We stopped doing, under the red line, there was no calculus, right? Above the red line, we did calculus, but below the red line, there was no calculus. It was just canceling, adding, things like that, okay? All right, so let's do a couple more and then we'll do the practice tomorrow. All right, so now we have, not arc, now we have an arc. That doesn't change anything. Just because it says the word arc, you can rewrite it.
The inverse of secant?
Yeah, it's just the inverse. So you can actually, if you don't like the word arc, change it to inverse of secant.
So use the product rule here? Or,
So 5s is actually the stuff.
so it's product and chain rule?
So yeah, so now we have, yeah, that's the next question. What are the steps that we need to do to find the derivative of this guy?
You use the product rule, and then when you need the derivative, you do the chain rule?
So we actually don't need the product rule. We actually don't need the product rule for this one. Why not?
Because the 2 is just going to be
Yeah, 2 is just 2. It's not 2x. If it was 2x, product rule for sure. So the 2 is just a coefficient. So we don't need that. So really all we need is,
Chain.
which is this guy up here. This guy has the chain rule already built in. You see where it says chain rule built in? So essentially we are using the chain rule. But when we're doing inverses, we just use these guys. So the top is stuff to the first, or the stuff prime, the derivative of the stuff. So what's the derivative of the stuff for that, for the one we're doing?
derivative of 5s is 5.
Mm-hmm. The stuff is 5s. So the derivative is just 5. And then we had bars. And then we had stuff squared minus 1. So what goes in the bars?
2?
Not 2. 5s, yeah, 5s. Now what do the bars mean? We don't really talk about these a lot.
That's the absolute value.
Absolute value, right? So what does absolute value mean? What does absolute value do? What is a function of absolute value?
Distance from it is to 0.
So it's distance from 0. So what's true about the distance from 0? It's always positive, right? Well, is that guy already positive? 5s? So we don't need the bars for this one. If it was negative 5s, you would need the bars. All it's saying is this guy in here, the guy in the stuff in front of the square root has to be positive. That's all it's saying. So if it's already positive, you don't need the bars. Is it wrong if you write the bars? No, absolutely not. Okay. And then stuff squared, so that's 5s, right? Okay. So we got 5 on top. You don't have to write the bars anymore since it's already positive. On the inside, we get 25s squared, because that's 5 squared and s squared, minus 1.
Why do we have a square root at the bottom?
Let's see, did it have a square root?
No, it does. It's just I'm asking what's the point in the square root if either way it's just going to be u and then it's going to be minus 1?
So u is always going to be squared, right?
Yeah.
Minus 1.
And then it's just going to go back to being u minus 1.
No, because of the minus 1, because we can't take the bars off. So even though, so this is difference of squares. It is difference of squares. But remember, to take anything, to get rid of the, are you talking about the square root or the bars? The square root. So to get rid of the square root, I have to have pairs, right? Because like the square root of 25 is 5, right? Because it's 5 times 5, right? That guy doesn't have a pair. It's difference of squares, so it's going to be, plus 1, 5s minus 1. It's going to be that, but those aren't pairs, right? They're not the same. So that's why we leave the bars. If they were both 5s plus 1 or 5s minus 1, they were both, then absolutely we could take away the bars. But we need pairs in order to do that. If it was just, like if that 1 wasn't there, yeah, there'd be a pair, right? 5 squared. Or sorry, 5s. 5s would be the square root of that. But because of that, we can't. So we have to leave the bars. Yeah, good question. Okay. All right, so let's do a couple more and then we'll be done. So let me give you a couple like you're going to see tomorrow. Just practice problems. Okay, let's see, inverse trig. Here we go. New problem, new problem, new problem. Okay, here we go. Call this one E. So we get f of x equals okay, there's the first one. And then do those two. All right, so the first one is inverse sine or arc sine. Okay, so I'm going to set it up here. According to my notes, it says stuff. So I highlighted the stuff. So it says at the top, the derivative of the stuff. So the derivative of 4x is 4. On bottom is 1 minus stuff squared. That's where 4x is going to go. So I get 4 over square root 1 minus 4x squared. Well, 4 times 4 is 16. X times x is x squared. Okay? That's as far as you need to go. Okay? F. This was arc cosine. Arc cosine is very similar to arc sine, except it has a negative at the top. So it's going to be negative 1 times the derivative of the stuff. The stuff is x cubed. So the derivative of x cubed is 3x squared. And on bottom, it's going to have exactly the same. Square root 1 minus stuff squared. That's x cubed. So on top, we get negative 3x squared. On bottom, I get square root 1 minus, if I have 3 powers and I square it, I'm going to have 6 powers. Done. That's as far as you need to go. Don't need to worry about anything other than that.